So I'm going to go over the financial maths questions you're doing today. First one you got perfectly. All we're going to be doing is do 24,000 and then each time we're going to multiply that by 0.75. So the next one's going to be 18,000. And then do the same thing to give you 13,500 and then 10,125. And then finally we're left with 7593.75. Part 2. Ignoring rounding, write the price of the card at the beginning of the year 10 in the form A by B to the n. So A is going to be the first, it's going to be 24,000. And then we're going to multiply this by B, which is the percentage that decreases, so it's 0.75, to the power of 10, because that's year 10. Year P is the first year of the model for which the price of the car at the beginning of the year is less than 1,000. Where P is a natural number, find the value of P. So here we have 1,000, and then we can do equals to and then change at the very end. So this is going to be using the formula used before, 24,000 times 0.75 to the n, or to the p here. So then we have 1 over 24 when we divide both sides with 24,000 is equal to 0.75 to the p. Now if we take the log of both numbers, we have the natural log of 1 over 24 is equal to the natural log of 0.75 to the p. That p, using our rule logs, our log rule, sorry, we can bring it to the front. So then we're just going to have p times the log of 0.75 is equal to the log of 1 over 24. And now we just divide both sides by the log of 0.75. So then we get p is equal to the log 1 over 24 divided by the log of 0.75. And if we stick all that into our calculator, what we end up is that p is equal to 11.047. In other words, P is equal to year 12. Use the formula for the sum of a geometric series to find the total amount of money paid for the car over the first 20 years of the model. Do not include the price of year for year 20 in your solution. Give your answer correct to the nearest €10. So we're going to be using the sum of geometric series. So that's going to be S of n is equal to A by 1 minus r to the n. And this is all going to be up 1 minus r. So here we have S20 is equal to A to 24,000 multiplied by 1 minus 0.75, and that's going to be to the power of 20. And this whole thing gets divided by 1 minus 0.75. Stick all that into your calculator and you're going to get to the nearest €10, 95,000 euro 700. So, I know I'm flying through these, but you got these the other day, so I don't need to open them. The price of a different car X years after it was initially sold is given by P of X equal to 25,000 by 0.8x to the power of X, where P of X is the price in euro and X is the real number. Use integration. So this one, you haven't done integration yet, so we're not even going to do it. So I'm just going to put an X through that, so you don't have to worry about it. Part C, explain what is meant by the present value P of a payment of €F to be received in T years time where the annual rate of interest is I. So you want to explain all of these. So what we can say is that it's going to be the amount of money that would be equal to F, which is the price, after T years at an interest rate of I. So the next one. Mark and E should buy a house for €280,000. They pay 15% of the price of the house from their savings. They take out a mortgage to pay for the remainder of the price. Their mortgage is for 25 years at an interest rate of 0.36 per month. So first of all, 0.36% is equal to a decimal of 0.0036. And then we have 25 years multiplied by 12 months because this thing is paid back monthly, which is equal to 300. So now we can just use the amortization formula, which is going to be A is equal to P multiplied by I times 1 plus I to the power t divided by 1 plus I to the t minus minus 1. So we have A is going to be equal to P. Well, first of all, we also need to figure out what the actual price of the house is. So if we forget that for a second, we know that they pay 50% straight away. So it's 280,000 multiplied by 0.85, which gives you 238,000. So that's the amount of money they're going to be paying back. So 238,000 multiplied by the interest rate, which is 0.0036, multiplied by 1 plus 0.0036 to the power of 300. Sorry, that should be a 6 there. And this all gets divided by 1 plus 0.0036 to the power of 300 minus 1. Stick all that into your calculator and you end up having that A is equal to 12,000 or 1,298.68 euro. Next, the value of the house is expected to increase at a rate of 4% each year, where or is an element of or. 10 years after America and I should buy the house for 280,000 euro, it is estimated that it will have a value of 350,000 euro. Use this to work out the value of or. So to do this one, we're just going to be using this formula, which is 1 plus, or, which is just the interest rate, over 100. And that's all going to be the power of 10, because 10 is how many years this thing's in for. And it's going to be equal to the ratio of 350,000 over 280,000. So what we get, this is equal to 1.25. So we have 1.25 is equal to 1 plus or over 10 power 10. So then we get the 10th root of 1.25 is equal to 1 plus or over 100, sorry. Then we need to just get the minus 1 on that side, so we get 10th root of 1.25 minus 1, and then we divide by 100, and this is equal to or. Sorry, multiply by 100. This thing times 100, which is equal to or, so or is equal to 2.26%. Question 5. A couple agreed to take out a 250,000 euro mortgage in order to purchase a new home. The loan is to be paid back monthly over 25 years, with the repayments due at the end of each month. The bank charges an annual percentage rate, which is equivalent to a monthly rate of 0.287%. Use the amortization formula or otherwise find the couple's monthly repayment on the mortgage. Give your answer in euro, correct the nearest cent. So as always, straight away write out the formula, just get extra marks. It's P, it's multiplied by the interest rate, multiplied by 1 plus I, divided by 1 plus I, and this is all to some power, so I'm going to put it to the power T minus 1. Fill this out. How many months is it? Well, it's 25 by 12, which coincidentally is equal to 300. So then we have A is going to be equal to P, so it's 250,000. And this gets multiplied by the interest rate. So we also have to say that 0.287% is equal to 0.00287. Or you can write it as 1 over 1.00287, but anyway, so we have 0.00287, and this gets multiplied by 1 plus 0.00287 to the power of 300, and this thing gets divided by 1 plus 0.00287 to the power of 300 minus 1. All that just goes into your calculator. And we end up with 1,244.06. Next, a little bit different question. Another couple agree to take out a mortgage of 350,000 at a rate of 0.3% per month in order to purchase a new home. This loan is also to be paid back monthly over 25 years with repayments due at the end of each month. The amount of each repayment is €1,771. After exactly 11 years of repayments, the couple receive a financial windfall. They decide to repay the remaining balance on the mortgage. Write down a series including the first two and last two terms, which shows the total of the present values of all the remaining monthly repayments due over the remaining 14 years of the mortgage, after the last monthly repayment at the end of the year 11. Hence, find how much the couple will need to repay in order to clear their mortgage entirely. Give your answer correct to the nearest 10 cent. So the first two terms, we're going to have the amount they're repaying divided by the interest rate. So here we have an interest rate of 3%. If we can find it. Or 0.3%, sorry. Right here. So that's all going to be over 1.003. And then it's also going to be the same thing because it's compounding interest squared plus, and then all the way up to the final repayments. And this is going to be to the 167 plus the final one to the 168. Where does that come from? Well, that's the amount of years times the amount of months that they're actually in this thing for. So we know that in total we have the sum up to 168 is going to be equal to A, which is the first term, multiplied by 1 over 1.003, or that's what the interest rate is, so you could just write 0.003 or write like that. And this goes to the power of 168 minus 1, and then it's divided by 1 over 1.003 minus 1. So this is just your regular multiplication, or your sum formula, sorry, which, if you do it correctly, is equal to 233,438.25. The next one, there is 3 questions in it. This last one I'm not going to do because questions like this never get asked anymore, and the answer is a little bit funky, so I don't want to confuse you in the rest of them. But for question 4, we have Neve has saved to buy a car. She saved an equal amount at the beginning of each month in an account that earned an annual equivalent rate of 4%. Show that the rate of interest compounded monthly, which is equivalent to the AER 4%, is 0.327%, corrected 3 decimal places. So this is going to be a changing interest rate sort of question. So we know that 1 plus some interest rate, which they don't tell us, to the power of 12, because it's going to be the year. This is equal to 1.04. So now we just have to figure out what this is. So we know that 1 plus whatever this interest rate is going to be the 12th root of 1.04. I is going to be equal to 12th root of 1.04 minus 1. And if we go ahead and figure that out, we're going to have that the interest rate is equal to 0.003274, which is equal to 0.327%. Next, Neve has €15,000 in an account at the end of 36 months. How much has she saved each month, correct to the nearest euro? So 15,000 is our answer, and this is going to be equal to some present value P, which is multiplied by the interest rate 0.0327 to the power of 36, plus the next term, which is 1.00327 to 35, plus all the way down to 1.00327 to the 2 plus 1.00327, and that. So that's going to be our series. In other words, we can just use the amortization formula for this. So we know that's going to be P multiplied by 1.00327, and that's multiplied by 1.00327 to the 36 minus 1, all divided by 1.00327 minus 1, which again is equal to 15,000. So you want to compute what's inside the brackets and then just divide 15,000 by that. So in this case, the brackets come out to 38.26327. So if we write that out, we're going to have 15,000 is equal to P times 0.26326387. And then if we divide both sides by what's in the brackets, we're going to get P is equal to the nearest euro 392. So if we go back up to this thing right here, or this whole thing right here, if we just sub in 392 right here, it's going to pretty much get us all the way to 15,000 when it's multiplied by what's in this box here. So I hope this helps. If you have any other questions, just let me know as soon as you can. I'll get back to you ASAP so that you have the answer to your test.